Good afternoon, everyone. Uh, I am Ankur Kumar, PhD research scholar from Jadavpur University, Kolkata, India. Today, I am going to discuss on first Qstr report on that's chronic and subchronic toxicity of diverse class of chemicals. In everyday life, human and other living organisms are exposing from the diverse class of chemicals. It have some of chemicals have acute effect, some have the chronic effect. Since the chronic effect required long time. So the chronic toxicity profile of chemical is utmost important for long-term risk assessment. Since several regulatory agency organizations are deeply concerned about the chronic or some chronic toxicity, because in the chronic toxicity, very few work is available. Because in some time, since chemicals, acute toxicity means quick effect is not seen, but after a long time, due to their accumulation, biotransformation, maybe their chronic effect is maybe there is a chronic effect. So concern is about the chronic toxicity assessment of these chemicals. Since in experimental condition, chronic toxicity assessment required large number of animal experimentation as well as time and cost. So best alternative is in silico approach to assess the chronic toxicity of these chemicals. So we have developed here the best alternative. We have developed QSR, quantitative structure activity relationship model using PLS method with the strictly adherent the OECD guidelines to develop our model for the chronic toxicity assessment. Here we have included different type of chemicals, which may be pharmaceuticals or agriculture or other consumer chemicals. In this, at first we have collected the chronic and subchronic data in the form of NOEL and LOEL, no observed effect level and lowest observed effect level in mg per kg per day from the literatures. Then we have curated chemical structure were downloaded from the PubChem and some were manually drawn using the Marvin skills. We have curated the data and calculated the descriptor using the AlphaDes software. We have divided the data randomly using in training and test set, which is usually in 70 into 30 ratio. Then we developed the model using PLS, partial least square method. Mainly we have feature selection we have done using the regression based stepwise regression and genetic algorithm. And from the base subset, we have selected the best combination of descriptor for the final model. These model were validated through the globally accepted different validation parameter. And finally, we have also checked the domain of applicability. And lastly, included the feature means mechanistic interpretation. There is a 5 OECD principle that is usually we have done as the first a defined endpoint, second is unambiguous algorithm, third is the domain of applicability checking, and fourth is the appropriate measure of fitness, and fifth is mechanistic interpretation if available. And from the GEACH model, we have developed 6 model, IM1 to IM6, IM1 to IM4 is IM1 and IM2 is chronic toxicity, and IM3 and 4 is subchronic, and IM5 and IM6 are the uh, intra-endpoint model. In this, some of the descriptor have the positive effect, means these are the responsible for toxicity assessment, and some have negative, means these have the negative effect on toxicity endpoint. Generally, chronic toxicity data we have used which have the toxicity assessment greater than 360 days, and for the subchronic, this is 180 plus minus 90 days for subchronic toxicity assessment. And from this model, we get this validation matrix of the developed model, and where we show the different number of latent variable and different number of descriptor for the final model development. From there, we can see that our models are square correlation coefficient and leave one out Q square cross validated are in the range of 0.6 to 0.9, and there is very less difference between Q square and Q square LO and R square. We show that model is robust, and also Q square F1 and F2, which is above the 0.5 and in the range of 0.6 to 9. Then MAE which is around 0.5, which also show
Yeah, one
that
moment.
our
1 minute.
of lowest in nature. And a scatter plot of the developed model also show that the predicted value and observed value are in similar, which show that model are predictive and accuracy. VIP plot of the developed model show that the importance of each descriptor, which are the NHM, number of heavy atom, and frequency of presence of sulfur and phosphorus bond at distance 1, which have the importance in this descriptor. Finally, we screen the drug bank database using the approved from the developed model and reported top 10 toxic compounds from the drug bank databases. Finally, we can conclude from our work that some of the features like lipophilicity, electronegativity, complex structure, unsaturation, halogen groups are responsible for toxicity assessment, enhancement, sorry, and feature like polar and hydrophilic group are responsible for toxicity decrease. So these features means the toxicity decreasing features should be present in the model, and thus our work finally we can conclude that our work will help to reduce the time, cost, resources, as well as chronic toxicity assessment of various existing chemical feature within the domain of development. Thank you everyone. Lastly, I would thanks to Dr. Kunal Roy, sir, with Kumar
Don't spend the
Ojas.
time. We know. Don't spend the time.
Okay.
There is some questions which you have to answer. From Vladimir Paroyko, which sources have been used to collect the chronic and subchronic data on chemicals? And how do you define the applicability domain?
Okay. We have collected the data from the available literature from the which are already specified in our reference. From there, we have collected the data in two endpoints. One is NOAA and one is lower. And chronic data, which is greater than 360 days, and subchronic data is 180 plus minus 90 days. And we have defined the domain of applicability, check the domain of applicability using the DMODEX plot.